Hi, my name is Nathan Richardet, and welcome to my breakout session for Introduction to VLANs. Whenever you get the file, it will be a folder that says Intro to VLANs, and inside of it will be another folder that says Introduction to VLANs. If you go into this folder, it will bring you to 2 lessons. So we are going to jump straight into the first lesson. So for this, you will need Packet Tracer up. I have it up to begin with. So we are going to go into the Lesson 1 document. So in this lesson, we are setting up 2 VLANs on a 1-tier network. And 1 tier just basically means that there's only going to be 1 router. The reason you would use VLANs in a network is to break up the broadcasting domains. A broadcasting domain is a group of addresses that will all receive a message whenever a router asks who is available. Without VLANs, you would only be able to have 1 subnet per port of your router, and with VLANs we can break it up into a bunch of little subnets, and this keeps unneeded requests off your network, which keeps the network running smoothly. And also you will see that we need Packet Tracer 8, so we have it preloaded. So first, we need to build our network, and by build our network, we need to pull out all the devices. So we will go to routers down here, we will scroll all the way to the right, and we will click the 2811 and drag it out. And next, we will go to switches right next to routers. We will go to the very last one as well, go to 2950, pull it out. And next we need 2 PCs. So we will go to in devices right here, and it shows you in devices PC. So in devices PC, and we need 2 of these, 1 for each VLAN. And I have created this so I know how it's supposed to be set up, but in step 4 it says this is how you should set it up. If you drag it out all willy-nilly, you still need to go through and set it up in this almost triangle format. So in step 5, we need to make the connections between all of these. And it goes through, so step 6, well, this shows you which wire we're using. So you click on the lightning bolt and you go to copper straight through, and it's the solid black line. Step 6, we are going to connect PC0, which is fast Ethernet 0, to switch, which is fast Ethernet 1. So this is the first PC, so we're connecting it to port 1, and it goes through and it talks about this. And then for the second PC, you know, it's named PC1, but that's because they start at 0. So we're going to go fast Ethernet 0, we're going to connect it to port 2. And then now we need to connect the router to the switch. So we're going to go port 24 to port 0. The reason we do port 24 for the router and not port 3 is because we put all of our routers in the last ports, and we do our PCs starting at port 1 just to keep it organized, add a bit of organization to your network. And if you notice, we have fast Ethernet 0 going down to the switch. We use fast Ethernet 0 instead of fast Ethernet 1 as an additional method of organization, because we have this saying in networking, zeros downs, ones across, which means that your port zeros will go to your inside networks, and then your fast Ethernet 1s will go to other networks. So if we had another router, we would connect those routers through their fast Ethernet 1s. And it's just another way of organizing your network so that you don't have to go back and do guesswork. So now we have 2 red lines here, green lines here, which we see in the picture. We need to go to the PCs and we need to give them IP addresses. So I show you that we need to click on the PC, we need to go to desktop, and we need to go to IP configuration. And that'll bring you to this screen, and we need to enter these settings inside of it. So we have 192.168.1.1 with subnet mask 255.255.255.0. This is the default subnet mask. In networking, it's really simple. It's kind of your base subnet mask. And then our default gateway is 192.168.1.254, so we will put that in the default gateway. And so the reason we have these IP addresses is, again, kind of like the ports on the switch, where your first computer goes on the first usable thing, which is .1, and then your router goes on the last usable address, which is .254. And it's just another level of organization. Organize it while you're doing it so that you don't have to go back and organize it later. And a bunch of different people organize their networks in other ways. Like some people always put their routers on 1, but in this we will be putting our routers on 254. So now that we have done this on the first PC, we need to go through and do it on the second PC. So to make sure they're on separate networks, we are going to go through and we are going to enter these settings, which is 192.168.2.1 with subnet mask 255.255.255.0, and then gateway 192.168.2.1 or 2.254. So this is .2 instead of this being .2 because we need these to be on separate subnets. So this 255 basically says that if there was since there's a 1 on the other PC and a 2 here, they are in different subnets. So they should not be able to see each other. If this was a 1 and this was a 2, so if it looked like this, they would be in the same subnet and there would be no point in having VLANs. So for this, we are going to do .2, .1. So they are both the first PCs in their respective subnets. So now to make sure that they can't talk to each other, which is what we want, we need to go and do a ping test. So we will go to PC0, we will go to command prompt, and you have this, you will type ping and you will ping the other PC's address. The other PC's address is 192.168.2.1. So we go ping 192.168.2.1 and it should fail. And this is good. This means that we set it up correctly and there is a use for our VLANs. And I'll talk about this more in a bit. So this should time out 3 times, which we will wait for. Okay, so it is timed out 3 times, which means that these computers cannot talk to each other. But we still need them to talk to each other. So we will go to the switch and we will go to the CLI tab. And so you'll see that, both of our computers are plugged in, as we can see here. And we will go to enable, we will type enable to go into executive mode, which just means that we can now go to configure terminal. And now that we're in configure terminal, we can start adding our VLANs. So we have 2 computers, so we're going to use VLAN 10 and VLAN 20. So you just type in VLAN 10, and then exit, and then VLAN 20, and then exit again. We also need one more VLAN for our router, and that will be VLAN 99. And the reason we're not using 30 is because 30 might be another VLAN on the network if you have more computers, and 99 is kind of the default native network. So we'll be exiting out of this to go back into configuration mode, and then we will exit one more time to make sure. So we go back into this executive mode, and then from here we can do show VLAN. And we are doing this to make sure that our VLANs are set up correctly in the switch. So we have VLAN 10, VLAN 20, VLAN 99. You'll see that all these ports are still in VLAN 1, and we need this port to be in VLAN 10, this port to be in VLAN 20, and this port to be in VLAN 99. So we will do that next. So here it talks about how you should see this, which is what we see. And we will go, okay, so here you can press space and it'll take you back to the switch. If you press enter, it'll send you line by line. If you press space, it takes you back straight into being able to type again. So we'll go back into configure terminal. And we will go to the interfaces that these are on. So PC0 is on interface 1, so we will type in interface fast Ethernet. This is one word, Ethernet 0/1. Now we're configuring that port. So we need to do switch port mode access. And this will, there are 4 modes that switches can be on. There's the default mode, which just means they're in VLAN 1 and they can see all the traffic that goes across the network, and it's extremely unsecure, but it's kind of the default for most routers or for most switches. We have access mode, which basically assigns them to a VLAN. We have trunking, which is kind of like VLAN 1, where it can see all the traffic going across it, but VLAN 1 has additional insecurities that creating another thing to trunk won't have. And then you have off, which is what we're going to set some of the other ports to in the second lab, which I will go through then. So right now, we're going to do switch port mode access because we were assigning this to VLAN 10. So we were putting it into access mode, and then now to assign it to VLAN 10, we do switch port access VLAN 10. And that assigns port 1 to VLAN 10. Now we need to do the same thing for port 2, except we're putting it in VLAN 20. So we're going to go and type interface fast Ethernet 0/2, and then switch port mode access again. And then, because we need it to be in access mode so we can assign it a VLAN, and now we're doing switch port access VLAN 20. And then now we have both of our computers assigned to a VLAN. We need to assign our router to a VLAN. So we are going to go interface fast Ethernet 0/24. And we will do switch port mode trunk. And we do switch port mode trunk so that the router can see both the traffic from PC0 and PC1 through their respective VLANs. And then we still need to assign it to VLAN 99 because this is our native VLAN, or this is our trunking VLAN. We need to make it our native VLAN to tell it that all traffic goes through it. So we are doing switch port trunk native VLAN 99. And that will assign the router to this VLAN. So now that we are done on the switch, we just need to configure the router. So if we go into the router, go to CLI, it talks about it here, we go into the router, go to CLI, we will type no for the initial dialog because we are ready to set it up. We will type enable, we will type in configure terminal, and we have 3 VLANs to make, but only 1 port. So to solve this, we do sub interfaces, and we do this by typing a period after the port. And we have sub interfaces, to keep the networks separated. So first, we're going to go fast Ethernet 0/0.10. So interface fast Ethernet, which is one word again, 0/0.10. And we will do encapsulation.1q. And the reason we do encapsulation.1q is and we do 10. This assigns, so this is just creating the interface, and this could be any number, but it is a good practice to keep it the same number as the VLAN that you intend to use it with. And then we use encapsulation.1q to tell that sub interface what VLAN to talk to. So for practice, we are using .10 with VLAN 10. And then to tell .10 to talk to VLAN 10, we are doing encapsulation.1q. So now we need to do the IP address. Our default gateway in PC0, if we go back to desktop, go to IP configuration, is 192.168.1.254 with the subnet mask 255.255.255.0, which are the commands that we will enter for this router. So we will go IP address 192.168.1.254 with subnet mask 255.255.255.0, which is shown here. We press enter. And now we need to do the same thing for sub interface for VLAN 20. So we will do interface fast Ethernet 0/0.20. Oh, I spelled it wrong. Put an extra H here. So now we are in this sub interface. You can retype out commands, or you can press the up arrow, and that will go cycle through your other commands. So instead of typing out encapsulation again, you can press the up arrow, go up to encapsulation, backspace 10, enter 20. And now for the IP address, we have to go to PC1. Its default gateway is 192.168.2.254 with the subnet mask 255.255.255.0. So we will go to the router and we will enter those commands. So IP address 192.168.2.254 with subnet mask 255.255.255.0. And that is this subinterface setup. Next we need one more, and that is for the native VLAN. So we'll do interface fast Ethernet, I spelled it wrong again, 0/0.99. I spelled it wrong twice. So now that we are in the subinterface for 99, we will do encapsulation.1q 99. But this is our native VLAN. This isn't any other regular VLAN, so we need to tell it that it's our native VLAN by typing native after it. And then because there are no hosts on this VLAN, none of it is using a default gateway, so we don't have to put an IP address. So now that we have all the subinterfaces configured, you will notice that the lines are still red, and that's because the line is still off. So we need to go turn that line on. So we will exit out of this subinterface, and we will go into the actual interface. So we'll do interface fast Ethernet 0/0. No subinterfaces, just 0/0, and we will do no shut. And that will, well, it's no shut down, but I used shorthand, so no shut. And that will bring all of the interfaces up as shown in the lab. And so now if we go here, we fast forward time a little bit because these are talking to each other. All of our arrows are green. So now we just need to test it. So we go to PC1, its IP address is 192.168.2.1. We go to PC0, get out of here, go into the command prompt, and then ping 192.168.2.1. It might fail at first, but we should get connectivity back. So the first one failed, second one, we have connectivity. And you might be thinking, well, you just went through a lot of steps whenever you could have just put them in the same subnet and they would have worked. And that's true. But let's say there are 24 ports here, right? One port goes to the router, so you have 23 computers. PC1 or PC0 pings PC1. You have, 21 other computers here. So whenever PC0 pings PC1, it will go to every port asking that port if it's PC1. With VLANs, it doesn't do that. It goes, who else is on my network? Nobody else is on my network? I'm going to send it up to the router. The router goes, oh, that network is down here, so it sends it back to the switch, and that switch goes, who else is on that network? No other ports are on that network? Okay, except for this one, so we're going to send it out this port. So instead of asking every computer if that computer is PC1, it asks the router, and the router tells it which one is PC1. So the traffic goes straight up and straight down. It doesn't have to flood the switch with additional packets that can slow down your network. And pings aren't going to slow down your network unless you have a lot of them. So it doesn't sound like it would make a much of a difference. But when you talk about like there's a ton of traffic going in and out of your computer every second, you are stopping all of that traffic from asking every computer if that computer is the one that it needs to talk to. It just goes straight to the computer that it needs, and that's why VLANs are helpful. So we have completed lab 1, so now we will go to lab 2. So we will exit out of this. We will delete these, and we will go to lab 2. I have a test for lab 1. It is just a pre-set up network, and you can play around in it if you want. It's basically just go and set up the same commands that you've learned in lab 1, and it should work. And if you set up different VLANs across them and make sure to give your computers different IP addresses, you should be able to ping across the network. It's just something to play around with to see if you really understand the content. So we will go back to Introduction of VLANs, go to the second lesson, open this. And then this one is a little complicated, so I do have a reference to show how everything will be set up. So open back up Packet Tracer. And so now we've set up simple VLANs, but a cool thing about VLANs is that you can use it for phones. So right now, on your desk, you might have a computer and you might have a phone sitting next to it, and the computer and the phone have their own separate cords. Well, with VLANs, you can make it so that only one cord runs from the switch to the phone, and then one cord runs from the phone to the PC. So it reduces clutter. It adds your phones to your network, which is moving towards more of the Internet of Things. It keeps phone lines off of the ground, out of your walls. It really cleans it up because, they're getting old. It's almost an outdated. It's basically an outdated system. This is just a better way to set up your network. And using phones puts almost no load onto your network. So to do this, we'll be setting up the topology like before. I've included a little picture to show you to where to get the phones. They're close to the PCs. So first we need a router. We will be pulling out the 2811 again. We need a switch. We will be pulling out the 2950, and we will need PCs and phones. So the phone is right here. Make sure you get the IP phone and not the regular phone. So we need the IP phones. We need 3 of them. Let's give ourselves a little space to work with. And then we also need 3 PCs, 1 for each phone. So we'll set it up like this, as shown. Now we need to go through and connect everything. So the first, so as you'll see, you use copper straight through as we used in the last lab. You click your PC, fast Ethernet 0. You click your phone, and you'll see that you have a port for your PC and a port for your switch. So this is coming from our PC, so we'll click PC. I'll use another one. This one goes to the switch, and we'll follow the same scheme as last time, where this is the first computer, so we will assign it to fast Ethernet 01. And then we will do every computer that way. So fast Ethernet 0, this connects to the PC, connect the phone. This is the second computer, so we'll connect it to fast Ethernet 2. This is the third computer, so we'll go fast Ethernet 0 to the PC port, and then the switch to fast Ethernet 3. And then same thing for the router as before, we'll go fast Ethernet 24 to the router, we'll go 0/0. And this is just the steps that walk you through that. And so after you have it set up, you'll have this like weird looking Christmas tree, right? So in the last lab, we had to go through and we had to set up all of the IP addresses for the computers for them to work. In this lab, we don't have to do that. We will be using DHCP so that the router will tell the computers what IP address to use and will tell the phones what IP address to use, and it will match the computer and the phone. Because with a computer, while it's really simple to configure it, because it has a keyboard and a mouse, with a phone, it's not so simple because it doesn't have a keyboard and mouse. So using DHCP is a really simple way to set up your phone and to make sure that your phone and your computer match. Before we do that, though, we have to turn the phones on to get rid of some of these red lines. To do that, you click the phone, you click the power charger down here, which it shows in the instructions, and you need to put it into this circle. So we will drag it over here. That circle. So we'll drag it there, and we need to do that for each phone. Exit out of here, and then do that for each phone. Exit out of there. So now, our phones are on, and they're trying to talk to the switch. And it should look like this when it's done, which our phones do. So now we have these green arrows. Speed it up a little bit. You can see that those orange dots go away. So it looks like these things are talking, but nothing's configured. So we have to go into the switch, and we actually have to start configuring stuff. So we go into the switch, go into the CLI. You can see that everything came up, which means that the phones have told the switch that, hey, we're here. We want to be on this network. So we're going to go into the switch, and we're going to do enable and configure terminal again. If your cursor gets stuck here, just press enter and it'll pull up the switch. So do enable, configure terminal, and now we need to start setting up our VLANs. So our first VLAN is going to be VLAN 10, and the name is going to be data. We're going to do it in all caps to show that we entered it, because as you will see, things in the router that we didn't do have a first capital letter and then lowercase letters, right? So we want to show that we did this by entering it in all caps because it won't match anything else that the router already has preloaded to it. It's just a form of organization that we use when setting up routers and switches. So we're going to do VLAN 10, name data. We name it data because these are the ones that the PCs are going to be used for, and the PCs are transferring data across the network. And we're also going to have VLAN 20. and its name is going to be voice. And because our phones are going to be in VLAN 20, so they're going to be voice. And we still need VLAN 99. And as we said in the last lab, it is the native VLAN, so we're going to name it native. And then one extra thing that we're going to do in this lab is we're going to make a VLAN, which in the lab I've called it 666. You can make it any other number you want as long as it's not these three. And we are going to name it the void. And this is just to put all of our unused switches on, or all of our unused ports on the switch on. Because I talked about in the last lab, all of these ports are in VLAN 1, which means that if anybody plugs into it, they have access to your network. So what we're going to do is we're going to throw them into this VLAN and we're going to turn them all off so that if someone plugs into your network, they can't get to your network. So now that we've created these VLANs, we are going to go and we're going to start configuring. So the first things that we're going to do is change the port that the router is on to trunking and assign that to VLAN 99. So we're going to interface fast Ethernet 0/24, and we're going to type it correctly that way that the commands work. I have a bad time typing today. And then we're going to do switch port mode trunk, and then switch trunk to native VLAN 99. And then we also have another command that we can use. So we have to configure all of these to go in the same VLAN. Since all of our computers are going to be in the same VLAN, but all of our phones are going to be in the different VLAN. So what we need to do is put them all in the same VLAN, and a really easy way to do that is to do it all at the same time. So we're going to go and do interface range to show that we're accessing more than one VLAN at the same time. And then fast Ethernet 0/1 through 3. And this just means that we are accessing ports 1 through 3. So 1, 2, and 3. And now any change you make here will change all the ports 1, 2, and 3. So we're going to do switch port mode access and switch port access VLAN 10. So this will let the computers be on VLAN 10. And now for the phones, we're going to do switch port voice VLAN 20. So this means that any phone that is trying to configure voice data across the network is going to go to VLAN 20. And this just makes it so that we don't have to configure the phones and the PCs, the switch and the router will do it for us because they're smart equipment. So we're working smarter, not harder. So now, as I talked about before, we're going to turn all of those other VLANs off, or all of those other ports off. We're going to throw them into our void VLAN. So we are going to go interface range fast Ethernet 0/4 through 23. And don't do through 24 because remember our router's on 24. Our computers are 1, 2, and 3, so we need 4 through 23. We're going to do switch port mode access. This makes it to where someone could change the VLAN of it, or this makes it so that we can assign it to this void VLAN, and then switch port access VLAN, and then whatever you chose to call your void VLAN. And then we're also going to do shutdown, and this turns them off. So our picture looks like this. So now, if anybody wants to plug into our network and try to use one of these VLANs, they have to pull it out of our VLAN that we have put it into to make sure that they can talk to the network, and then they also have to find a way to turn that port back on because we have turned it off administratively. So it's creating hoops for them to jump through so that they can't access our network. And we also have to do the same thing for our gigabit Ethernets. So we're going to do interface range gigabit Ethernet, making sure I type this right, 0/1 through 2, and then switch port mode access, switch port access and then the name of the VLAN that you chose to make. And then we will also shut these down. And you'll see that these are changed, these are down, these are down. So now we want to go exit out of all of this. You can use Shift Z, or you can use exit twice. And we're going to do show VLAN to show that we have, or our void VLAN with all of these ports in it. We have voice with 1, 2, and 3 in it. We have data with 1, 2, and 3 in it because our phones and our PCs are using the same port because they're plugged into each other. And then we still have fast Ethernet 24 in the default, which it's trunking. It just says it's here, but it's actually in 99 and it's trunking. But because it's trunking, it gets all wonky with the way that it wants to show it. Yeah, so if you see, you'll notice that port is still set in VLAN 1, and that's because it's set to trunking. So now we have the switch set up correctly. We need to set up the router. So we go to the router, we go to CLI, and we don't need to do a ping test this time because we didn't give them IP addresses. We have to tell the router to tell them what IP addresses to give them. So again, would you like to enter initial configuration dialog? We're going to say no because we're going to set it up ourselves. We're going to go enable, configure, terminal, and we need to set up, we have to set up VLAN 10 for these commands. So we're going to do interface fast Ethernet 0/0.10. We have to tell that subinterface that we want it to use VLAN 10, so we're going to use encapsulation.1q10. And then we're going to give it the IP address. Uses 2 words. 192.168.10.254. Common practice is, our VLAN, since we're using 255.255.255.0, the third number increases by 1. So since we're using VLAN 10, we can use .10. You can, it's really, if you know subnetting, you understand how it works. But for right now, we're using VLAN 10, so we're just going to use .10. And then we're going to use 255. Make sure there's a space there. 255.255.255.0. And we need to do the same thing for VLAN 20. So we're going to do interface fast Ethernet 0/0.20. Encapsulation.1q. And then, VLAN 20. And then IP address 192.168.20.254 and then 255.255.255.0. And we need to set up the native VLAN also. So interface fast Ethernet 0/0.99. Make sure that you type in your words correctly, and then encapsulation.1q99 native. And again, make sure you spell your words correctly, otherwise the router will tell you that it's wrong. And then we also have to go back and turn the interface on. So exit interface fast Ethernet 0/0, no shutdown. And you'll see all the things come on. So now we have it set up like before, but again, nothing is configured down here, so the router can't actually talk to these. So we need to go in and set up, our DHCP. So in basic config, we're going to press exit. We're going to make sure it just says config. You're going to do IP DHCP exclude address. This says exclude and then it says exclude address because if you type excluded, they're just supposed to be excluded. You can press tab, and if you press tab, it'll autofill the command for you. So we're going to do 192.168.10.250 to 192.168.10.254. And this is just saying, hey, Why is this being weird? This is just saying, hey, you know, our router is on 254, and then if we want to install like a printer or something, you know, we're giving ourselves some extra address space that we can install static addresses to them. So this is just saying, don't put these addresses in the DHCP pool, which is saying like, if something connects to our network, don't give them any of these addresses, and those are for us to use. And then we also need to do the same command, but with the addresses from our voice VLAN, because you know our phones also have a default gateway. So do 20.250.192.168.20.254. So now we have these addresses excluded from our DHCP pool. We can now create our two DHCP pools. So we have IP DHCP pool data, and this will go straight to our computers, and we're going to tell it to go straight to our computers because we're going to tell it what network it's on. And that network is 192.168.10.0.255.255.255.0. So this all works together because up here we said this is our default gateway, which is 192.168.10, and then 254 is the last usable, so it's .10.0 through .255, and 0 is the name of the network, and 255 is the broadcast address. So our usables are 1 through 254. We have this address tagged to VLAN 10 through this encapsulation command, and that is all going through this subinterface. So down here, when we use network this, we are saying, hey, this data pool is going through this network, which will send it up here, and it'll be like, oh, that's for VLAN 10. You know, those computers are VLAN 10. So because in the switch we did switch port access, so it is basically just like following a line of where it's like this goes to VLAN 10. Okay, this goes to VLAN 10 because we tagged it as VLAN 10, so it sends it to VLAN 10 to the switch, and then the switch says, oh, VLAN 10 is for the computers, so we will give these IP addresses to the computers. And then we need to do our default router, which will just tell every computer that is on this network the default router, which is like the default gateway from before, 192.168.10.254. And then again, I used the tab command right here, so I didn't have to type out the whole thing. And now we have to do the same thing for voice. So we're going to press exit, and we're going to do IP DHCP pool voice. And so now in here, we kind of have to do the same thing. We have to do network 192.168.20.255.255.255.0. We have to do our default router. I'm going to press tab again so I don't have to type it out. 192.168.20.254 because I messed up my command. If you press the left arrow, it'll delete it. 192.168.20.254. Press enter. And then we have to do this option 150. And this just tells the router that it's voice traffic, and this is the default gateway. So now we have our DHCP pool set up. We can exit out of this, and now we have set up voice traffic for our phones, but we don't have the voice service set up. So to do that, we're going to go in and we're going to type in telephony-service, and that will let us configure this. And in here, we are going to, this is how we're going to set up our phones. So we need to know how many phones we're using. We're using 3, so we're going to use max dn3, and that's just how many numbers do you want it to have? We want there to be 3 numbers, so dn is dial numbers. So even though there's 3 dial numbers, we still have to tell it that there's 3 phones. So we're going to do max ePhones 3 as well. So now we need to tell where are we telling these phones to talk to? So that is the default gateway of our second VLAN, our voice VLAN, and then port 2000 is the port that we're sending the voice traffic through. So we're doing IP source. I'm going to press tab so I don't have to type it out. 192.168.20.254, and then port 2000. And make sure you type it in correctly, otherwise the router will yell at you. And then so now we have to go through and we have to tell the router what we want our numbers to be. So we have 3 phones, so we have to give each phone a number. So we're going to do ePhone dial number 1, and that will tell that, hey, we created a phone and it's changing its interface to up. And we want that number to be 1001. And it doesn't matter. You can use any number that you want. We're going to use 1001. So now I press the up arrow so I don't have to retype these commands, but we're going to do ePhone dial number 2. So it changes that state up to as well. And we want that number to be 1002. And then the same thing, ePhone dial number 3. We want that number, one second. We want that number to be dial 1003. And I accidentally pressed a thing and it pinged it. So don't worry about that. So now we need to tell the router what phones there are. In Packet Tracer, there's only one phone type, so that's the phone type that we're using here. So we have to go exit out of this, and that'll bring us to base command. We need to go into ePhone 1, tell it that its type is 7960, and then we need to tell its button is 1-to-1. That just means, hey, the first phone is 1, the second phone is 2, the third phone is 3. So if you wait a little bit, it'll say that this is registered. So now we need to exit out of this and go into ePhone 2. Same type, because they're all the same type of phone, so 7960. And this is going to be button 1-to-2. And again, if we wait a little bit, it'll tell us it is registered. So there we go. And then now we're going to exit again. We're going to go into ePhone 3. We're going to do type 7960. We're going to do button 1-to-3. And if we wait a little bit longer, it'll tell us, yeah, it is registered. So sometimes instead of getting this message that your phone is registered, you'll get this message over here that says need to configure the phone MAC address or the VM station ID. If that happens, you need to go into the phone, grab this, drag it down here so that it unplugs it, wait a little bit, and then plug it back in, and then go back into the router and reissue the button 1-to-3 command, and it should work. Because it's packet tracer and because phones are screwy sometimes, you have to try a couple times because not everything's guaranteed to work on the first try. That's why, like in lab 1, I was like, the first ping might fail. If that fails, you just have to wait on it. In this, it might fail the MAC address. You don't worry, it's okay. You just have to unplug the phone and plug it back in. And if it doesn't work, you may have to try it a couple times. I know that when we were first learning this, one of our classmates had to unplug their phone and plug it back in like 8 times because it just wouldn't take it. It's okay. So now we have everything configured, all of our devices have registered. We need to test the phones. So we will go out of our router and we will go into the phones. So if you go into the physical and you go into the GUI, you can see that the phone's got certain addresses. So the first phone is 102, second phone is 101, and the third phone is 103. And if you want them to have certain numbers, like I said up here, by unplugging them and plugging them back in, if you configure everything in the router and then turns your phones on, your first phone will be 101, the second phone you turn on will be 102, and the third phone you turn on will be 103. It's just how do you want to do it? If like in this lab, for example, the numbers didn't matter, so we turned all of our phones on first. If you need the numbers to go to a certain phone, you configure everything in the router and then plug the phones in. So now, to make sure that our phones work, we will go to phone number 0. Its number is 1002. So let's go to phone number 3, pick up the phone, and call call 1002. And you'll see that it's ringing out, and you can hear it ringing. That is because phone number 1 is ringing. If you pick up the phone by clicking it, it'll say connected, and that means that your phones have successfully been configured. So congratulations. You have now set up phones with VLANs. So this is the end of Lab 2. Like I said before, if you have any problems, I did include a packet, and it shows the completed lab. You might have to speed it up a bit. Yeah, and it'll, have everything on it. Or it is configured. So, this is 1001, this is 1002. You can pick up this phone, call 1002. It'll call this phone. You can pick it up and they'll talk. And then if you're missing any commands, you can just go in and kind of poke around with a show run command, and that'll show all the stuff that I have set it up. So you can check my DHCP excluded addresses, you can check how the data pools are set up, you can check how the ports are set up, etc. So thank you for coming to my breakout session, and I hope you guys retain this knowledge for the future, because it is incredibly useful, and VLANs are used in almost every network, and they're part of the future. So thank you.